Up our Jython script so that we can now use FIJI to look at our image of our simulated cells or random circles, and we can detect how many cells or circles we have, the size of them, the area, and we can export that into a CSV file. Now what we want to do is work with Python and some built-in libraries so that we can open the CSV file and explore the data and do some basic data manipulation and plotting. So the next section of this quick course, what we're going to be doing is first importing the data from our CSV table or any other source. You'll learn how to import it from any other source. Then we're going to just do some previewing of the data, some data validation, and some basic statistics of the data set, make sure that we're on the right track, that when we look at our data, it sort of meshes with what we think it should be, so that we can check to see that our code that we wrote previously to do some analysis isn't completely out of left field. And then we're going to do working with our data, just selecting columns, doing statistics on columns, sort of things that you'd be normally doing in any sort of quick Python scripting, and then just some quick plotting so that we can see what our data looks like, again, just as a sanity check to see what's going on. So the first thing we're going to do is use Python's built-in functions to import CSV files. And we're going to use this to read the data in as list. So we're going to start with import CSV, just for comma separated variable. And I'm just going to initialize an empty list to put our rows in. So then this is the syntax to open a file with open. This is the file that we saved, results random circles corona time, as CSV file. So this is a preferred syntax, at least that I like to use. Just because it will keep the file open as long as we're reading, and then it'll close it so we don't have to remember to write close at the end of every time we open a file. So read CSV is just going to be CSV reader. This is the function we're going to be using, is CSV, and then the delimiter, we have to specify which delimiter we're going to be using, and it is just a comma for comma separated variable. You can use other readers for tab or space, etc. And then for row in read CSV, we're just going to print our row. So let's just give that a shot right now. And again, if you have to specify the path, if you saved this file somewhere other than the same location that you're running the script from, you might have to specify that path to somewhere else. So if we go through and look at the result for row in read CSV, we're just going to print every row. You can see that our 0th row is just an empty holder here, area, min, max, and then you can see that for every row it's reading in. This is our cell number, 1, the area, the min and the max. These are the min and max intensities. So because we had thresholded it and it was a binary image to begin with, then we have every min and every max will be the same. It'll be 255. Makes sense. So area here. So what happens if I bring this in now? Well, let's see. Well, if I want to just look at, instead of every row, if I just want the cell number, I can just write row, print row. Well, if I just want the cell number, it'll be 0, because that'll just be this first entry. Remember, Python is 0-based, so here's this. Enter, and I get, well, interestingly, there is, remember, a blank space here. So that's row 0. And if I want, let's see, the cell number, so that's column 0 rather, not row 0. If I want the cell number and the area, that'll be column 0 and column 1. Well, let me comment that line out. Alright, so now we've got our cell numbers and our areas. So now we can see all of our areas and the number of cells. What we need to do is then make a list from all of these. So we've already initialized an empty list. So how do we go about putting them into the list? Well, again, we just use append areas list.append. And for each row, we want to put in the second column. So entry 1, and we run that code. So let's just take a look at that list. And you can see that the first entry is actually the word area. So we want to get rid of that first entry, so how can I go about doing that? Well, if I look at areas list. I can get rid of it, so all I want to do maybe is set areas list equal to areas list then show it, and here we are, 1649 through 437. Looks like it was up here. So we just need to remove the first entry by slicing from 1 to the end. Remember again that 0 is the first entry, so we have sliced this area out. So now what happens if I try to add a number to this first entry? So let's take a look at that first entry now, areas list 0. 1649, so if I add plus 1, I should get 1650, except I get an error. If we look at these, all of the entries in this areas list are still strings. They're not numbers. So how do we go about changing those? That's a good question. So let's see, float areas list 0 plus 1. So what did I do here? I'm calling the function float on the entry areas list 0. So on 1649, this first string entry here, I'm calling the function float, which turns this string into a float. And then I'm adding 1, and 1649 plus 1 is 1650. As you can probably guess, to find the min of the areas, we just use min areas. So we can use a statistics package to determine standard deviation of the areas and a lot of other things. So we can just, from statistics, import standard stdev for standard deviation, and we can just pull up the standard deviation of our areas. So we saw that we could import data using built-in CSV import functions from Python. We could do some simple statistics pretty quickly. But what we really want to get into is data frames. And data frames are a function from Pandas, or an object rather from Pandas and NumPy. And instead of just reading in a CSV and building up our own arrays, what we can use is just Pandas built-in functionality to read in a CSV and get a data frame out. So here we're going to import Pandas as PD, import NumPy as NP. And I just wrote the syntax quickly, df old, because we're going to see df new in a minute, or just df. So for data frame is pd.readcsv, our file name. And I'm using skip rows equals range 21 to 101, simply to make sure that we don't have anything after the 20th. So if you ran the same script more than once, when you were looking at your Jython script to look at the cells, you may have accidentally appended to the same CSV file, so this will just keep the first, 20. And so then if we just say df old.head, it'll just show us the 5 first entries of the data frame. So we can see cell 1, area, min, and max. If I do tail, well, I can see the last 5. If I do head 10, I see the first 10 entries. If I do sample, say let's do 5, I get a sampling of 5 entries from inside. And this is actually really useful because you might have beautiful data for the first 5, you might have beautiful data for the last 5, but if you just do, say, sample 5, sample 10, then you can sort of see if there might be a mistake someplace in there that you're not seeing because it's just in the first 5 entries. So here I'm going to do the same thing again, but here I'm setting index call for index column equals 0. And you can see the difference. Let me just put this back to head. You can see quickly the difference is here it's got the index column for 0, 1, 2, 3, 4, 5, as you'd expect from Python indexing. Here we've turned this column, right here, 1, 2, 3, 4, 5 into our index column. So now we're indexing by 1, 2, 3, 4, 5 by the cell number. Now we can find out information about the data frames as a whole using those Pandas functions built in, which is quite useful. So here we're going to be working with df. This is this index column equals 0, df. So let's find df.info. And that tells us that there's 20 entries, 1 through 20. There's 3 columns total, and there's 20 non-null area entries, 20 non-null min and max entries. That's important because maybe if we have one entry that doesn't work or didn't come in, then this might be 20, 19, 20. And that'd be important to know when you're looking at your data just to make sure that you verify that everything is there that should be there. You might miss one if you've got a 10,000 entry data set, and this says 10,000 non-null, this says 9,999 non-null, and this says 10,000 non-null. Then you've got to go back through and see what you had, and there's an error. So we can also look at df.shape just very quickly. It's similar to image.shape, and we see we've got 20 rows and 3 columns. So some really quick exercises. Find the min, max, and standard deviation of the data frame columns. So I'll give you the first one. To find the min, it's df.min. And you can see, well, I gave you a hint for the next one. You can see what the minimum of the area is, and you'll see the other ones. So give that a quick shot. So that was a pretty quick and easy exercise, but let's just go through it really quick. df max. We get 1649, 255, 255. That's going to be... So df.mean, this will give us the mean of all 3 columns. We can do the same for df.standard deviation. And of course, min and max have no standard deviation because it's the same value for all entries. And lastly, df.describe is a beautiful way to quickly just see what our standard deviation is, our min, our max, our quartiles, our total count. So it's a really easy, beautiful way to just quickly take a look at your data set and see what kind of data you have. So what if you want just the data from a single row entry? So I'll bring up df.head, and you can see our different rows here. We can use LOK or iloc, so location or integer location. So the first one, df.loc, we're just going to call row 1 and all the columns. And you can see row 1, 1649, 255, 255. Now let's look at iloc. df.iloc. Oops, yep, I did spell that right. Row 1, all columns of data. And it's 1185, 255, 255. Now what's the difference here? So loc looks for a particular label on the index. So here, because we had set our index column 0, so here we set our index column to be the cell number. So cell number 1, 2, 3, 4, 5. It's looking for that label on the index. So loc 1 will give us 1649, 255, 255. It's giving us that first entry. Integer loc looks for the integer number from the index, the position of the index. So here we're looking at 0, 1, 2, 3, 4. So this first one here is going to be, in fact, our second entry, because now it's going back to base Python indexing. Now this is important to note because sometimes you might want to just look for the second one, but you don't know what you don't want to deal with what the index is, because we can change these indexes to be other things. I call this alpha, beta, gamma, delta, epsilon, and it wouldn't change anything. If I used iloc, I could still call it by 1. So now that we've looked at how to find the values for a single row, we can look at selecting a single column using indexing, which is more what we're going to be looking at for the rest of the day. We want to look at just the areas. So I can bring it back up, dataframe.head, and if I use a single bracket here, I can preview just the first 5 values of the area, df.head, and you can see that it's coming out as a Pandas series. If I use double brackets, df and then I use 2 brackets here, what I'll get back is a Pandas data frame. Now what's neat about that is I can then of course set that, so maybe areas df is going to be df area, and we can look at, see, add a new line here, areas df.head, and you can see that I just have the first 5 entries of just my areas. So I've taken this whole data frame, just taken out the first column here, and it's got the same indexing areas as it was here, and I can just work with that data frame. There is one more way to look at just a single column. I don't recommend it, so if I do df.areas.head, df.area.head, I also get the same results back as a Pandas series. Why I don't recommend doing this is it won't work if you have spaces in any of your titles. So here, because it's in quote marks, I could have the space. Here I can't, so this will fail in some instances, so it's just best practice not to do it, but know that it does exist because sooner or later someone will use it. So now that we know how to select the data from a single column, we're going to work with that and do some statistics of it. So I have a link here. There's tons of different functions that you can use on a data frame. Let's just start again with describe. So just for area, describe, we have the standard, the min, the max. So standard deviation, rather, the min, the max, the quartiles, and the count. So I can do that again in a series version. If I wanted to, I could pull out, say, just the count by doing that. You can also just instead use dot count instead of dot describe to get the same value back. If I want the min, I can do that in either the series or the data frame approach. And so as a quick exercise, what I'd like you to do is find the min, the max, and the mean of the area column and set them equal to area max, area mean, and area min, and make an output print statement showing what they are. So here I've just got a sample. I'd like you to go and finish that with max and mean. That should have been a fairly quick and easy exercise. You should get something like area min equals data frame, single brackets area.min, .max or .mean for min, max, and mean, and then just a simple print statement. You should have gotten 437, 1649, and 829.8 if you're using the same data set I was. The random circles corona time CSV. So what I'd like to quickly go over now is formatting numbers, just because this fits here better than anywhere else. When you're writing up a print statement, sometimes you need to format the number because it's very long, and it's just a quick way to put it into a print statement so that you have significant digits and you don't have 17 digits trailing off or more decimal points than you really need. So let's just quickly set, here's a test number, 1234.54927. And if I want to just have one number after the decimal point, I just put a :1.1f.format test number. And that just prints as a string, you see 1234.5. If I did 2, I'll get 2 after the decimal point. You can see that it's rounding for me, .55. If I do 3, 549. If I do 4, it keeps rounding for me. See 5492, that would round to 5493 because this is the 7 here. Now what I want you to be careful of is if you start putting extra digits, so I did 21 accidentally earlier, it will fall apart because now it's trying to fill decimal points that don't exist in your number, and you're just going to get extra crap, really. So just be wary of that. But then I can write my print statements again with significant digits, and there we are. So 2 after the decimal point, I can make this a 1 after the decimal point, 1 after the decimal point, 1 after the decimal point. So the reason we started with a test image is so that we could then look at the results we get after processing and compare them to what we know the ground truth should be from what we put into the system when we made our test image in the first place. So looking back, we started with a list of radii that had an average of 15 and a standard deviation of 4. So now we know what our areas are from all of these circles that were detected by FIJI in our Jython script, and we pulled them in using Pandas. So now we want to find what the radii are from those areas. So we can recall that area equals pi r squared, and so the radius is going to be the square root of the area divided by pi. So how do we write that out? Radius is going to be equal to numpy, that's square root, it's a numpy function, df area, so we're going to operate on the whole column of area divided by pi dot pi. And I can look at radius dot head to see the first 5 entries. So we've got 22.91, 19.42, 14, 16, 13. So this looks like it might be fairly correct. We have, again, we should have our mean of 15 and a standard deviation of 4. So that might work out like we expect. So let's continue doing some other things and we can look at it. So what if I want to perform a mathematical operation and add a column to the data frame, say, as you might be doing in an exercise later. So I could say df, let's see, df, and I can make a new column, radius 100, and that'll just be equal to my radius times 100. And if I pull up df.head, you can see that I have a new column here. It's just my radius times 100. So this is obviously something I don't want. I don't want an extra column in here with data that doesn't really mean anything. So how can I get rid of that? Well, that's fairly quick and easy. I can just reset my data frame df to df.drop. And I'm going to drop a column. Columns equals, well, radius 100. So let me just take a look at what that looks like. df.head. And you can see just area min max again. So can I add the radius to the data frame directly? Well, yeah. So I can just say df, make a column for radii. It's just the same function that we had up here, same equation up rather. And df.head. You can see now that I've got area, min, max, and my radii all in one data frame. So what I'd like you to do is compute the diameter and add a diameter column to the data frame. It shouldn't be too terribly difficult, but just give it a quick shot. So it's fairly easy, hopefully, for everyone to find how to just put diameter in there from radii. So df diameter, we're just making a new row, or a new column rather, it's just data frame radii times 2. So here we're just making a new column in our data frame and setting it equal to the radii column times 2. Take a look at that and you see radii diameter. So lastly, I'd like to just find the mean and the standard deviation of the radii and compare that to what we put in our sample image. So our mean radius is just going to be df radii.mean, and I just wrote a print statement here using our formatting that we learned earlier, and the mean radius was 16 pixels. Originally we had said 15. And if we do the same thing for standard deviation, we find the standard deviation is 2.91 pixels. If I find that's after formatting, otherwise you'd get something like this out. And actually, just out of curiosity, what would the mean radius look like? Mean radius would be 16.00284. Now, these are different. Of course, we had our set for mu to be 15 pixels and our standard deviation to be 4, and here we get 16 and 3. So what could we expect? What might be the rationale for that? Well, we only have a sample of n equals 20. So we can do a quick plot to see what the distribution of these radii look like. So now we just use this magic function, matplotlib inline, import matplotlib, and import matplotlib pyplot as plt. So just run that code. So with such a small sample, what we might want to do is take a look at a plot to see what our distribution really does look like. So you can start by putting this magic function in matplotlib inline, so we can see plots inside our Jupyter notebook. Import matplotlib and pyplot, and just take a quick look, and we see this is our radii here. I'm sorry, this is our area here. We've got min, max, radii, and diameter. And this plot isn't really helpful. It just plots every different part of the data frame. So our max, of course, is the easy one to see, 255. Our min would be underneath that, which is why we can't see it. So why don't we just take a look at what the radii look like alone. So now you can see that radii and area look very similar. That does make sense because radii is directly proportional to our area. So how would I go about looking at this in a different way? Well, we can call the same thing. Let's just say df radii. Look at just that column. And now I want to just call a plot on that. Alright, that's the same as this. But what I can do inside my plot function is put a kind, so the type of plot we want is a histogram. So hist, and our width of each bar is going to be 0.8. You can experiment with this, but I found it works the best for this. And you can see that we don't have a really great Gaussian distribution because we only have n equals 20. That's why we have a average and a mean, or an average and a standard deviation that are off of what you expect. So if we made this into 100 or 200 cells, we might well get something that is more what we expect. That's about all I'm going to be covering in this particular section of the course. If you have time and you want to have some more experience, what I would suggest is doing the same workflow and working it up on the comma-separated variable results table you got from looking at the simulated cells. Everyone will probably get slightly different answers depending on the workflow you used in your Jython script, but it'd be interesting to see what you have. I'd like to thank you for taking some time to do this course, this module rather, with me. And if you have any questions, we will be answering them through the image.sc forum, and we're hoping to do office hours now and again through YouTube Live.